All right, hello. So I've been on a little journey. It's very interesting. Like when I so I've been doing things over the past almost 2 years. That hasn't really been building on my experience working on like complexity of building rich web experiences. And even though I kind of played around with things, the thing that really bothered me in terms of like actually working on a product was null referencing. So basically, when you build like a rich web experience with a lot of state management, like separating the state management from the UI is a really, really good pattern in my experience. It just simplifies the mental model so much, and it's much easier to scale and refactor and all of this stuff. The challenge though is because I'm old, right? TypeScript, I didn't start with types, and when TypeScript hit, what I noticed is that, and we can even write some code for this. So an example of this would be, we can do this. It's like maybe you have this session class or whatever abstraction you use. And in this session, you might have a user or you might not have a user, right? And this is a big problem with global state stores, because if you rely on React and specifically props passing, you would just pass the actual user down to the component that actually requires that user, right? And then the contract between the components would ensure that that user would always be there because you're passing it as a prop. It's like, what term should I use? It's like at type checking time or compile time, let's call it that, even though you don't compile JavaScript. At compile time, you know that a user will actually be there because you have this strong contract between the components. And that's kind of what I've been exploring, is like, okay, how can you create the same strong contract using global state stores? And I've been playing around with like state machines and all kinds of concepts to try to kind of achieve this, like almost like mathematically correct way of expressing state. And then I realized that maybe there's a more pragmatic way to look at this, because I felt stuck so many times. And I come from this world where pragmatism is king, because I've been working in startups. You have to move fast. You have to be really pragmatic. But this has just really bothered me. And I haven't found a good way to really express it. So what's interesting about this, which was a huge realization for me yesterday, I was just writing a comment, and then it suddenly hit me. Like, React really represents this super well. So when you have, we're gonna talk about the async stuff later. So when you have a component like some feature, and you say, I need a user here, and I'm gonna get the user, whatever. So when the parent component uses this feature, you have type checking that ensures that you actually pass the user down to that component, and then you have type checking for however that parent component gets the user, right? So from the root component down to some feature, you have like, I don't know the right term, but like mathematically, like at compile time guarantee, I should say that, at compile time guarantee that that user will actually be there. But you might have to pass the user down 20 components, right? And that's the problem. Then that's where the cost is. Yes, you have a guarantee, but the cost is managing that contract through 20 abstractions. So what do we do? Well, we do this. Use user. This is what we do. And this is what we call depending on how you implement it. Well, first of all, you're bypassing the contract, right? You have no guarantee other than your own understanding of the application. Like, you know that this feature will only be mounted when we have a user, but there's no contract in the code that explains that. So what we do is that we favor not having to pass the user down like 20 abstractions versus having that guarantee, right? And this is pragmatism in a nutshell. And the way you could express this hook is use user. So let's say we have that session thing. So if session, so if no session dot, oh, come on, session dot, dot user, you throw an error, new error, no user available, or you return session.user, right? So what you get now is you get the correct typing, like you will always have a user here, but this is what we call an invariant. And I've heard about invariants, and it's, for me, invariance has been like immutability. Like, okay, immutability, what is immutability? Oh, it's when you're changing an object, the key of an object, you also change the reference of the object. I understand how it works. I understand that an invariant is a function that guarantees that you only return one variant or it will throw. But what do you actually use it for, right? How does it help you? And this is what it helps with. It helps you being pragmatic. It helps you explain a contract without all the ceremony. So the contract here is, okay, we need a user for this feature to work. That's the contract. But you are responsible for upholding that contract, right? And the nice thing about React, which React didn't have before, is what we call error boundaries. So if you were to do a mistake here, you can make sure that this feature has an error boundary. So only that feature will actually get into a problem if you made a mistake. So it's not like the whole application fails. That's also something you have to manage. But this is how you solve this stuff, I think. That's like the pragmatic solution. And then what you would do if you do a global state store is that depending on the state store, what does an invariant look like, right? So it could be a hook, like I just showed you. But for us in ReactX, that would just be a getter. So we will have like authenticated user. Why is this failing? Oh, maybe because it doesn't return anything. So if no this user, we'll throw new error, no user, or we'll return this user. So now we have an even stronger contract, right? So you can go and check if there is a user or not. But if you point to authenticated user, you will get the authenticated user, or it will throw an error. So that the reason I say it's even stronger, it's just the naming. We say authenticated user. So that signals to you that when you use this, it needs to be in a context where the user is authenticated, or it's gonna throw. Yes, and then how this ties even more into things. Yeah, is this a transition into async? Well, no, it's not a direct, not directly. But yeah, so I guess this, yeah, I was just wondering if I'm going to create a bridge or not. But I think this is the thing, like after thinking about this for like 2 years now, I think diving into all kinds of different solutions, trying to figure this out. And I was discussing this with Claude as well, just like as an ecosystem, as a civilization, have we actually reflected on this? And there's like several papers on pragmatic coding, right? And invariance is part of that. And there are like titles of, or the tension between like being guaranteed at compile time versus being pragmatic about runtime kind of thing. Because the point is that if the cost of having guarantees at compile time creates code that's really hard to reason about, then that is a very high cost, as opposed to, okay, no, it's going to be super easy to reason about it, so that when you actually use that invariant where you are responsible for using the state in the correct context, it was easy to reason about why that invariant works in that context. It's very interesting tension. Yes. So I'm really happy about that. And then the other thing I was reflecting on is async. So I've also thought a lot about how do you deal with async state? Like, is there a primitive for async state? And like the main primitive we have in JavaScript or TypeScript is a promise. So the question becomes more like, can we use a promise to represent an actual state? So the promise itself is the state. And what's interesting about React is that it got suspense, which basically, so inside like object-oriented code, it's no problem to have, yeah. So for example, the count here is a promise. So, so as you can see here, like you can always like just await this dot count. It's very easy to get the value or wait for something or whatever it is. Like you can manage promises very easily in object-oriented code, but you are not able to do that in React until suspense arrived. But there's such a high cost to it, because in the context of building a UI, there's just so much stuff you want to do. So you want to, where should I even start? Like, first of all, you want state to be global, because this count might change inside this component, but it's referenced way over there in that other component. You want to make optimistic changes to it. You want to fetch it, update it in the background. You want to tie it to a subscription. Like, there's so many things you want to do with that state. And if you wrap it in a promise, all of that stuff just becomes harder. And especially if you use React's primitives, because they're very low level. So then you're like forced to go into abstraction mode, which is the very thing I don't want this tool to be. It should just be object-oriented code, basically. So this is an example of how this works, and it's like completely mind-bending. So if I were to do, let's just do that. Wait, I can. So if we were to do only this, I never learned a shortcut for creating a comment line. So if we do only this app.count, so this is how you consume a promise in React, and this works, but you've created this like indirection in the sense that if that promise is pending, somewhere in some other file, there's a suspense boundary that takes care of that. or if it rejects, some component somewhere in some other file takes care of that, hopefully. And that makes sense if you have a shit ton of nested components that all individually do data fetching. I don't know if you've seen Facebook's presentation on why they introduced GraphQL. It's basically that. Like, every component has some data fetching happening, and they need to orchestrate that. One thing is orchestrating in terms of doing efficient calls, requests for data, but also efficient loading states for fetching that data. It's super, super fascinating stuff. And it's very, very impressive what they built for Facebook to work. But other people don't build Facebooks. Like the kinds of applications I work on, they have a lot of complexity, but it's not data complexity. It's all the state around that data in the client to create a user experience. So using suspense has a high cost, or has a cost. Or the cost becomes higher because you don't gain the benefits of it. What's the other thing? Yeah, and another thing is that suspense was also designed for streaming, so that React knows when to load components based on data fetching happening on the server. And this isn't a thing in the kinds of applications I built, because they are strictly client-side applications. There's no server rendering at all, because these are applications that you use for hours during the day. It doesn't need server-side rendering. So that doesn't make any sense. And then the third thing is using suspense and transitions is there to help you prevent tearing. But this only works with React's primitives. This doesn't work with external state management. So like start transition and stuff has absolutely doesn't help at all when you do external state management. So I'm like, from all the challenges I've met doing like these complex state management or wielding complex state management in these rich applications, data fetching and async indications in the UI has never been a problem. That's not the problem. Right? So why go and embrace these complex primitives created by React as opposed to just do the simple thing? Be pragmatic. Because you can see here what you have to do. So first of all, if this count, so the first time this component renders, we have a count, and that count is still pending. So it throws to the suspense boundary. But then when that count updates, we're using the deferred value to pass that new count promise into a background render, which is going to also throw to the suspense boundary. But because we use deferred value, that is just going to evaluate in the background. And only when, and then this component will get the old value that is already evaluated, which is going to work and it's going to render. But as soon as React applies that pending tree, component tree, it's going to re-render this again. And now the new render is okay, and it returns the new promise, and then that will work, and everything renders fine. And then we have, okay, but what if you want to optimistically change that value? Then you have to use optimistic. So you have like, you have the actual promise, you have the deferred representation of that promise, you get the value out of that promise, and then you get the optimistic version of the value of that promise. And now you can check if the count is not equal to optimistic count. you can base that on, okay, is it like in a pending state, which is not really true. But when you want to change that optimistic count, you have to use a transition, but that transition doesn't matter because we're changing the count inside an external state store. But optimistic requires this. So you get an error if you don't use it. Like you get a warning. It still works, but you get a warning that you don't have it in a transition. And React is even like automatically wrapping start transition in props that's called action. Like it's so like integrated and complex that it's just insane. But again, it makes sense for React, but it's just, yeah, what I want to say is that this has just put me down on this path of what the fuck am I doing here? We don't need all this stuff. But as I said, this is not really representing the pending state. If you want to represent the pending state of increasing the count, then you have to do a use transition, which gets its own transition with a pending state that you use here instead. And then you get a true transition. So even if the value is the same, but it's still pending, it will show as pending. So it's like, it's crazy complex. So if I were to like do this without using a promise, let's see, what we would do is that we have like an initial count, or we would have like a null, like it's not initialized. But if it's null, starts as null, right? Then you would use then you have kind of two choices. Well, you don't really have two choices. So what you really do, depending on how you want to express it, you can do like is loading initial count or something. It's like false. And then you, I'm going to be very explicit here. So initialized count, return. So if count is, let's just write it. This.count equals null. Count is not initialized. Like it's super weird using a count there, but it's just conceptually. So the thing is, you're creating these states that is not really like tied together. In the sense that they can change individually, and you're like in charge of orchestrating this. But if you're explicit enough, you understand the contract between them. So in this case, you would look at is loading initial count, and that would start as true, and then you would load it in the background. And then as soon as that's loaded, you set the count, you change is loading initial count to false. And now initialized count is a valid thing to use, which is like completely decoupled, right? It feels, this gives me like an itch, but it's very pragmatic. It like fits your mental model of like, okay, I need to load the initial thing. I want to know when that's happening. Okay, let's create a state for that. Okay, we need to have the count, but it can be null, or you would just start with this and you didn't even need this, right? This is the most common thing, is that you do have an initial default state. That's the most common thing. So that means that you don't even need like an invariant for it. You just want to know if you're loading it initially or if it's refreshing or whatever it is. So that's kind of, and it solves everything. It solves, okay, now that state is global. It's available to any component. You can easily do optimistic updates. You just change the value in place. And the whole UI becomes optimistic by default. So if you show the count one place and you show like a notification somewhere else, because at a certain count, sorry for using the count, but if the count is more than 5, we should show this thing. That's a different component. That would also still just work, because you're treating your state as also being the optimistic state. But then you can do things like, what's it called? Like you can use explicit states for it as well. And that makes you, that just makes sure that you, you create a relationship between the states. So it could be, I'm going to use count again, sorry about that. So you can say is loading true, value null, error null. So it's actually typed like this. So either it is loading true and these two are null, it's loading false and you have a value but error is null, or loading is false, value is null and error is a string, for example. And that's also something you can use then in every component, but you can still have like an invariant for it. So if that count is being used like many different components, like nested in the component tree, you create an invariant that guarantees that that will throw an error if the value is null, basically. Oh, agent workflow. On your channel for agent workflow. Yeah, I jump all over the place. Do you mean like I'm talking about things unrelated to agent workflow suddenly? Yeah, I'm all over the place. But yeah, and this is even better, right? Just have the states. Don't like, because I've been trying to like hide these states inside the promise, because the promise already has these states, right? But invariance is the thing. Like even in an action where you would like await a promise, rather having an invariant that throws like the magical thing about an invariant is that even though it throws, it's kind of an excuse to, well, I guess that's arguable, but it's kind of, if you have a promise, you have to kind of put it in a try catch. Well, yeah, I guess that's also kind of an excuse because you don't have to do that, but it's the same for an invariant. It's kind of an excuse that, okay, if this fails, we have a fallback for that. You don't check invariants, at least not in the context of what I'm talking about, in place. You have like a general error handler. It's a fallback thing that kind of isolates the throwing of the error, because the throwing of the error represents a broken contract, which shouldn't happen. Yeah. Anyways, so that was my journey the other day. And I'm pretty happy about at least having that perspective. We'll see what happens so we move on. But that's how I think about it. So what I'm gonna do is, it'll be a short stream today, but I'm gonna remove all of this. Oops. And let's see. Yeah, let's move this. Let's move the count. And then I'm just gonna show them. So here we have the same thing. Use app is like an invariant. If we don't have an app, then we're gonna throw. And this is kind of, this is provided at the root of the component tree, so it works in any component. So it's kind of silly, right? Because people get upset by this type signature, including me, but it's true. Like when you use context, you don't have a strong contract that context value will actually be available. So this is the correct typing, but that means that you have to create, like creating an invariant is the way to, I don't know if there's any other way really, but creating an invariant is the way to bypass that null. Like some people say like null as unknown as the thing, but that's wrong. You should create an actual invariant. Like it's not wrong, but it's kind of hacky. Well, this is not hacky. This is an actual concept in programming. Cool. So then for patterns, I made some changes, because what's nice about this is that we don't like try to introduce this like new magical suspense thing. It's just state. So we have composing state, lazy initialize state, per key one instance state, scoping re-renders, we have services, testing, blocking async data. Wait, didn't I remove that? Wait, what happened there? Didn't I pull? Wait, this is wrong. I removed those. Wait! There's something weird going on here. Am I on the right? On branch main. What the hell? There's something really weird going on here. First of all, drop those work tree. What the fuck? Like, why is the patterns wrong here? This isn't the oh, now it's updated. Is it correct now? Wow. Look at that. There is no blocking. Wow, does it cache it? It's not the correct contents. Let's reload the window. Hopefully that's super interesting. Yeah, look at that. Okay. So we have services, testing, and then we have dependency injection with T syringe. And this is really interesting. What's tokens? I don't think you need that. Oh, yeah. We could have reflect metadata. Yeah, we should change that. Let's see. Could you change the T syringe? Oh, that's. Could you change the T syringe example in the docs to not use a token, but use reflect metadata? So we don't have to like pass those tokens around. It just cleans up the example. So dependency injection is kind of the same. Like, yeah, that's what was actually one of my points. So when you are pragmatic, right, you don't create this like strong contract like props passing is through React components, use context instead. You kind of have the same for services and state. because you might have a lot of nested state, and then you want to just use a service, right? You want to do some HTTP calls or whatever. And it's the same. You have to pass that from the root of the state and pass it down to all the nested classes. But with dependency injection, you bypass that. It's exactly the same thing. So you create these, So you create these classes that basically represents the interface. So this is because now you can mock the services very easily. You can create services. If your app runs in different environments, you can use the same service interface, but they point to different things in the different environments. It's just good measure. And then when you implement the actual thing, it shows. So here you have browser HTTP and browser persistence, and you make them injectable. You register them, and then you are able to inject them simply by making them private in the constructor. So that's pretty, and it doesn't matter. It can be like super nested. Like as long as you have, I'm not sure if you need singleton. I think is it injectable? Yeah, it's probably true. Whatever. You have to decorate the class that you can inject something in it, and then you just do this and it gets injected. So you just bypass everything. Don't have to manually pass into the constructor. There's a challenge though. If the class requires custom params in the constructor, then that doesn't work as well. I haven't really explored that too much. But yeah, anyways. Yeah, maybe I should explore it a bit before I write about it. Yeah. Yeah, because you have to create this like factory thing. But still, it's all about complexity. It's the same for a React component. Like if you have a simple component React application, you just pass props. If it gets unwieldy, you create contexts, and that is basically dependency injection as well. So this t-syringe is like the context representation in the class world as compared to React. Anyways, invariants, some state is nullable at the top level but guaranteed non-null in certain contexts. An authenticated user or load a resource a selected item rather than threading null checks through every component that can only ever render when the value exists. Define a getter that throws if the invariant is violated. If the invariant fires, it's a programming error, not a runtime condition to handle gracefully. This is the same contract use context enforces when you throw on missing provider. The guarantee lives at the boundary. The route, the provider, not scattered across every consumer. Exactly. Yeah. Wait, what is this? Yeah, whatever. Cool. Anyways, so that's where I'm at now in my thinking. Docs. So let's stop there. But yeah, this was nice for me to kind of settle on, and then I think we should do a stream and just build something with good old programming, and then we'll rather use AI for the boring stuff that we don't really need to discuss. And then I want to explore how well AI understands just using classes. Right? This is the interesting thing. There's really nothing for the AIs to learn. There's no library to learn. There's no interface to learn. It's just classes. It's just plain old code. Like, you may have some conventions that you want to enforce, but that's true for any code. And the reason React works so well for AI is because it's so insanely heavily trained on it. But we avoid the tricky hooks. Like, AI doesn't understand suspense if you use the low-level primitives, like use deferred value with use and then use optimistic. And it's incredibly complex because it doesn't have the training data for it. And it's so fascinating, the React presentation on Async React, which it's a genius. It's really is a brilliant presentation, because I can't remember his name, but he's on the React team, and he kind of just goes through, and I don't know if he's like honestly stumbling, but his point is to stumble, showing the complexity of the low-level primitives, and then show that these primitives were never intended for you as the end consumer of implementing React. They're built for library authors. So they can create state management solutions that, or data fetching solutions or whatever, that works with React. Yeah, it's a really good one. Anyways, that's it for now. And